Well, brief reminders. This particular assignment will be due next Wednesday, but we're going to grade it together in class so that you guys have it graded with you to study from during the week. We'll grade it in the class. We'll talk about, refresh on everything that will be on the test because it will be next Friday. I originally said it would be on the date that is next Wednesday, but I wanted it to be on Friday so that we have that Wednesday to study. So that is coming up, and since it's a week from today, just as a reminder, it will be on all the things we've covered so far, which the order that I've labeled them on Brightspace is order of operations, how to use calculators, polynomials, quadratics, and Trig geo. I also usually like to have practice questions available for students to just have something new to do for practice sake. So I'll try to upload some of those to Brightspace that you can work on if you want to. They would be completely optional though. In the past, my students just like asking for new things to practice with instead of just looking at old stuff again. So if that sounds appealing, that is an option for you guys. So we covered a lot of ground last time. So there's really only one extra thing to review before we've covered all the individual pieces needed to do this assignment. So I want to go ahead and cover that briefly, and we can spend as long as the rest of the period you guys want to stay just doing examples together. So on the second page, the upper rightmost section asks you to perform sine, cosine, and tangent on a specific angle and a specific triangle at some time. It also asks you to do secant, cosecant, and cotangent. Have either of you never used those three before? Are they completely foreign to either of you? Okay, very good. I can never remember them, frankly. I remember they exist. I can never remember how they relate to the other ones. I keep mixing up the fact that sine relates to cosecant and not secant, and cosine relates to secant and not cosecant. So I've got the relationships right here on the board. First is good old SOHCAHTOA. Second is how secant, cosecant, and cotangent relate to the triangle sides. So you draw the same triangle, you still pick an angle, and the cosecant would be the hypotenuse over the opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So you could, if you wanted to, make a second acronym for SOHCAHTOA. Doesn't roll off the tongue nearly as well though. And in addition, if tangent theta is opposite over adjacent and cotangent theta is adjacent over opposite, that must mean that tangent equals 1 over cotangent. So they all relate back to the original based on being inverses. So all their relationships are right there because I always have to look it up and I don't want you guys to have to hunt that down. already talked about with the addition of those 3 additional trig functions. We've talked about each individual concept needed to do this entire assignment. And that will frankly be the bulk of the trig. Actually, that will be all of the trig that you would need to remember for future physics classes. So at this point, we can focus on, for as long as you guys want to. If you feel like you're comfortable, and we can call it here, but we can spend time working any questions from the assignment we want to together. I think it would be good to talk about these together, because I think these are the most head-scratchy ones in terms of figuring out what to do and in what order. So I think spending some time on these would be good, but we can talk about any that you want. 90 degrees. So the thing about cosine tangent is they won't really work from the perspective of the 90-degree angle. Because from this angle, the opposite is the hypotenuse. So, for example, sine of the 90 degrees, opposite over hypotenuse would always be 1. So sine of 90 degrees and cosine of 90 degrees will always be either 1 or 0. Okay. Sine of 90 is 1, cosine of 90 is 0. Meanwhile, sine of 0 is 0, and cosine of 0 is 1. So these functions always have to be from one of the other two angles, which is why I will always just label this as this is the right angle. We know it's 90 degrees, but we can't really use that number except for this type of step. What I do recommend is we can use either of these two angles to find the height of this leg and the length of this leg. Those are both very important numbers because this leg is going to be shared between both triangles. At the start of the problem, after we cut the triangle in half, we didn't know anything about this one. We had no numbers to fill in. So finding this vertical leg of the left triangle tells us the first piece of information we know about the vertical leg of the other triangle. So that is a very important number to find. The other important number to find in terms of getting information about this other leg is the bottom leg. So that's the next step I'm going to do up here. I'm trying to make the left triangle orange. I'm going to do the right triangle in green. So we did from the hypotenuse and from the 31-degree angle, we did sine to find the opposite leg. So let's use cosine of that same angle to find the adjacent leg. Do either of you disagree with 5.14? Okay. So that's going to give us 5.14 centimeters for the bottom leg of the left triangle. With our physical situation here, what can that tell us about the bottom leg of the right triangle? Sorry? Yes, both of these legs have to add up to 8. So we can just subtract this out to find how much left is on that side. So I'm trying to use blue for things that relates to the entire triangle as a whole. 8 would be equal to the 5.14 plus whatever that other piece is. So that mystery adjacent leg should end up being about 2.86, I believe. Yes. And with that number in place, we know two legs into the right angle of the rightmost triangle, which is enough information to start filling things in. Excuse me. Since we have the two legs, I'm going to use a Pythagorean theorem to find the hypotenuse of the rightmost side. Anybody disagree with 4.2? Okay. So our ultimate goal is to find the dimensions of the entire triangle. And now we know all three sides, which is convenient. We have all three sides of this triangle. What we still need is these two angles of the rightmost right triangle. This angle will just be the angle of that corner of the big triangle too. This angle will be part of the overall angle for the whole triangle. So we still need both of these numbers. This one will be the end answer as it is. This angle will need to be added to the other one. Yes?
Could you use a negative tangent to that top angle?
Yes. We could use inverse tangent to find both of them. You just have to be very careful about what you put where. So I'm actually going to label both of those angles very quickly using different Greek letters, just to help clarify. I'm going to call this one theta and this one, actually forget what that letter is called. That's another letter that commonly is used as an angle measurement if you've got more than one. I just forgot what it is. That is phi. Phi. Oh, no. We don't have any Greek life that use that letter on campus, do we? Anyway. So, if we're going for theta, so let's do tangent theta. From that angle's perspective, the opposite is going to be the 2.86, and the adjacent will be the 3.09. From the other angle's perspective, the opposite is going to be the 3.09, and the adjacent is going to be the 2.86. You don't necessarily have to use tangent for both of them. You could use, since you know all three legs of the triangle, you can use sine or cosine or tangent for whichever one you want, but they will both have different perspectives on what leg is opposite and what leg is adjacent. So that's very important to keep in mind. Additionally, once you find one of them, you could use the all angles add up to 180 trick to find the other one. So there's multiple ways to figure it out. Just if you use this trick, keep in mind the different perspectives on opposite and adjacent. So we now have these two angle measures. I'm going to rewrite them over here. We got 42. Because that is the total angle of just that whole leg. Oh, sorry, this whole, the whole triangle. So, now we have the leg of all the full legs of the entire triangle. We've got two of the full angles of the entire triangle. Last step is just to add these two together. And that should give us 100 and something. About 101.8 degrees, which we can double check by adding with the other two angles to make sure the whole thing still adds up to 180. And it does. So I say this triangle is complete. Any questions on anything at all? Okay. 8 will be very similar. It might actually be a little bit more straightforward because here we already know one angle of each. And we don't have to divide the one length, we know up into pieces. That would also be 45 degrees. I think 8 might be even more straightforward because we can assume each of the angles without much difficulty. The last thing would just be finding all the lengths. You would still need to find this length and then add them together. But I think that's the trickiest part of number 8. We can do 8 together if you guys want to stick around for it. But I do think this one's probably more straightforward. You guys have everything you need for 7 written down? Okay. Let's look closer at 8. Okay. Eight is drawn at a weird angle, because of course it is. We are told the bottom right side is 6.32 feet. The top right angle is 18.43 degrees. And the left angle is 45 degrees. Now, what I would, looking at this, first thing I would think to do, we can go ahead and divide the triangle. We can also go ahead and figure out every single angle present, so that we never have to find another one again. Our triangle division will be here. Form those two right angles. In the leftmost triangle, we've got 90 degrees and 45 degrees. What should that leave this remaining angle as? Yeah. If it's a right triangle and one angle is 45 degrees, the other one also needs to be 45 degrees, which means this triangle is a little out of scale, actually. I might just tweak my drawing slightly. then on the other side, if this is 90 and this is some other number, we can pretty quickly find this piece as well. I'm going to label these as 1 and 2. So for triangle 2, 180 is equal to 90 plus 18.43 plus unknown, which means that last angle is about 71 and a half, I think. What we can do with those is add those two numbers together to find the total angle of that entire joint of the triangle. I've got 116.57 from that. And we can further check that by adding 116 with 45 and 18.43, and that gives us 180. You could have also done that in reverse. Since we know 45 and this, you could have started by finding this number, and then we can assume this one's 45, we can subtract 45 from this to get this number. So you could do that in reverse order if you want to. But that tells us every single angle, and we never have to find another one of those. The really three sides that we're looking for are this one, and this one. And I think we can actually do this without having to find this middle leg. Because funny thing about this type of a triangle, I forget what the word for this one is, but if we find this leg, oh, hold on. No, I think we do need to find the middle leg, sorry, because we don't actually know any of these lengths. My apologies. But once we find one of these two, the other one should be the same thing. No, nuts, sorry. Let me rewind, I apologize. Sorry. The hypotenuse would be its own thing, but these two legs would be the same. I'm terribly sorry about that. So, we do need to find this middle leg. It'll be the same as this leg. And since we don't know any of the lengths on the leftmost triangle, we're going to have to use the rightmost triangle to find this side. At least to begin with. So, let's go ahead and use the right triangle to find this leg and this leg. I'm going to go ahead and I'm going to call those, from the right triangle's perspective, let's call that one B and this one A. Now, the perspective as to what is opposite and what is adjacent depends entirely on what angle you're starting from. And since we have both angles that aren't the right angle, we just have to pick one and stick with it, or diagonalize from there. So the question gave us this one, so I'm partial to starting from this one. From this angle's perspective, if we were trying to find side A, that would be the adjacent. So I would do, so we know this angle, we want the adjacent, we know the hypotenuse, so that's CAH, cosine of 18.43 equals the adjacent leg on this side, just call that A, divided by 6.32. Now about 6 from that. So I'll go ahead and write in. And from the same angle's perspective, B would be the opposite. So I would use sine for that. That gives me about 2 feet. But you guys disagree with anything so far? Okay. That's every leg of the rightmost triangle, which doesn't tell us any whole sides of the big triangle yet, until you look at the left side. And again, fun fact about right triangles with two 45 degrees in them, this leg should be identical to this leg. Remember that rule? So, since we found that piece, we could do the math, and I will in a second just to prove that it works, but that's one extra leg that we pretty much already have for free, meaning the only thing we still have left to find is this piece. I will prove very quickly, though, that that rule does still work, though, so that so let's say from 45 degrees, we were looking at opposite over adjacent. This works because tangent of 45 degrees is 1. You can check that yourself. Tangent of 45, as long as your degrees mode is 1, meaning that these two numbers should just be identical. So it doesn't really matter which of the 45 degrees you're starting from. One of these numbers will still be 1.99, so the other one's going to be 1.99. The hypotenuse, meanwhile, we could actually just use that Pythagorean theorem here if we want to. And with that, we have every angle, this side, this side, and just need to add these two numbers together real quick to find the whole length of that third side. Which is, I'm being super precise, I'm not rounding up these numbers. If I was rounding these numbers up, the answer would just be 8. But we're just going to keep 7.76 for now. Sorry, 7.996. Excuse me. Those are, I think, those are the two that I think are the most time consuming on this particular assignment. Any questions about anything at all? Okay. Is there anything that you guys would want to look at before we break for the weekend? That's basically the end of the assigned class period, so I say we break here for the weekend. Be working on this. Let me know if you have any questions over the weekend. You can email me, or hunt me down in my office during next week. And if either of you are interested in practice questions with that, I'll be putting some of those up soon. If not, don't worry, they're completely optional. I'll just put up an answer piece so you can check your work and be reviewing the last couple weeks of materials in addition to working on this particular assignment. Thank you both. Let me know any questions as they come up, and have a wonderful weekend. It's actually been kind of warm lately, but it's definitely still going to be wet all weekend, so stay dry and warm and healthy. All that good stuff.